All right, we're going to cover the topic of average atomic mass. Um, so you're going to need your periodic table out for this and a calculator to practice with us. And a piece of paper would be helpful too. Okay, so average atomic mass. So the mass number on the periodic table is an average of all the masses of a particular isotope. So we're going to see this in a bit. So not all isotopes of a particular element will have the mass found in the periodic table. So for example, silicon here, if you look in your periodic table, the average atomic mass is 28.086. That means of all the isotopes of silicon, that would be the average. So you can take a sample of silicon and you can find some isotopes with like a mass of 26 AMU, a mass of 27. There's some silicons with a mass of 28, some silicon with a mass of 29, some isotopes of silicon 30. So if you took the average of all of your sample there, you would get 28, meaning that silicon 28, that isotope, is the most prevalent one because that's close to the average. So somewhere around 28, that's where you're going to mostly see most of your silicon. So you're getting an average of all the isotope masses that you have for each element. So we're going to practice doing this. I'm going to be toggling between this PowerPoint and then like a practice worksheet. Okay, so how do you find the average atomic mass? So for given problems that you'll have, you're going to determine the number of each isotope present in a sample. So for example here, if I scroll over to right here, okay, let's work with a sample of neon. Okay, so we have neon 20, and in the sample we have 450 atoms of it. Neon 21, we have 15 atoms of it. Neon 22, we have 3,678. So we're going to make a total row here. And we're going to be kind of extending this because there's another column we're going to add in a bit. So the total, so the first step number 1, is to add your total number in sample. So if we do that right now, 450 plus 15 plus 3,678, we would get a total of 4,143 atoms that we're working with. Okay, so that's the first step. The second step is to multiply the mass number by the total number of isotopes in each sample to get your total mass. Okay, so what that's going to look like, and we're going to add another column here that says mass. Okay. Okay, so what we're going to do is take the isotope mass for neon 20, which is 20, multiply it by the number in sample. So the second step is to get your masses. So we're going to multiply these mass numbers. So 20 times 450, so just to kind of reiterate what I'm doing here, 20 times 450. So you should get 9,000 if you're doing this along with me. 21 times 15, you get 315. And 22 times 3,678, you get 80,916. So you want to add up the total number of these. So that's what determined the total number of samples. We did that determine the total mass. Okay. So we're going to figure out the total mass now by adding up these results here. So 9,000 plus 315 plus 80,916. So your total mass should be 90,231. Oops, that's a 231. Okay, the last step is to find the average. So you're going to divide the total mass, so the bigger number we just got, by the total number of samples. So our total mass is 90,000. So I'm going to say my average here. And my average, okay, so I'm going to do 90,000 the total mass of my whole sample, divided by the number of atoms in this sample. So 4,143. So divide those two numbers, and you get 21. We're going to round to the tens place, so it's like 21.77. So we're going to say 21.8 as your average. So that would be the answer. So just to take a look at why that makes sense, if you look, your neon 20 was a majority of your sample, 3,678. So your average answer in AMU, to be technical, your average answer should be closest to the isotope that has the most abundant atoms in your number of sample. So the 20 and 21 are kind of pulling the average a little bit away from 22, so that's why it's 21.8, not exactly 22. But just to kind of see if your answer makes sense, look and see which number of sample, which one was the biggest one for your given mass. So in this case, neon 22, we're close to 21.8 with 22. All right, let's try one more. We'll try this with krypton here. Okay, so krypton, 69, 70, 71, 72. Okay, the first step is to get your total in sample. So we're going to add our sample here together. Oops, okay, page keeps on toggling. All right, I need to, there we go, that'll work. Oh, okay. Okay, so add up the total here. So 323 plus 323 plus 167 plus 5,788 plus 2,687. So the total you should get is 8,965. Okay, 8,965. Now we need to get the mass for each isotope based on the mass number and the total number in sample. Okay, so do you remember how to do that? So if you remember that you multiply the mass number times the number in sample, then you are correct. So 323 times 69, 323 times 69, we get 22,287. 70 times 167, so 167 times 70, you would get 200. Oops, 167 times 70, not plus. You get 11,690. So make sure you're kind of double checking if you're typing things in correctly. Like I just noticed I pressed the plus sign instead of the multiplication sign, so I noticed my number did not look like what it should have been. So kind of keep an eye on how you're plugging in your numbers and if you're doing the right plus or doing multiplication signs and whatnot. Okay, so 71 times 5,788. So you should get 410,948. And then 72 times 2,687, you should get 193,464. Okay, so that was your second step. The third step here is to add your total mass. So get your total of your whole mass here. So we have 22,287 plus 11,690 plus 410,948 plus 193,464, and you get a total of 638,389. Okay, so just to kind of, before we do the last step here, we see that to kind of estimate what our answer should be around, we see that the most abundant is at 71. There's a kind of a decent amount of 72 here, not so many of the krypton 69 and 70. So I'm thinking your answer is going to be kind of in the 71, 72 type of area. So kind of a somewhere around there, not so much in the 69 or 70 area, a little closer to 71 and 72. So we'll see if we're kind of right there. All right. So your last step is to get your average. So step 4, get your average. So the average is going to be the total mass. So you want to take a big number divided by the smaller number. If you flip-flop and put the 8,000 on the 8,965 on top of the 638,000 number, you're going to get a number less than 1, which your average has to be between 69 and 72. So you know that's incorrect. So make sure you put the mass number on top. 638,389 divided by 8,965, my total number in sample. So let's see what we get. Divided by 8,965. So you get 71.20. So we're going to say 71.2 AMU, atomic mass unit. So 71.2. So we were correct to estimate we'd be somewhere kind of between 71 and 72 based on our number of sample. So again, nice way to check your answers. Okay. I think the next one is going to be one that you're going to try on your own and see if you get it right. Okay. Thank you.